Hi students, we're going to continue with ionic bonds. Ionic bonds continuation. So just now we were talking about sodium and chlorine and how we form the ionic bond for them. Let's have a look at how it's done, guys. What you have is sodium plus chlorine giving us sodium chloride, right? Now we want to form the ionic bond of this. We said that when we form an ionic bond, you have a transfer of electrons. So let's do this, guys. I'm going to show you how to draw the diagrams. The first thing you want to do is to draw sodium plus chlorine atom. Okay, so sodium atom is 2.8.1. So I'll put sodium in here, 212.8, 1, 2, 3, 4, 5, 6, 7, 8 dot 1 plus sign. Chlorine atom is 17, 2.8.7. For sodium we use dots, so for chlorine we should use crosses, or we can use crosses for sodium and dots for chlorine, it doesn't matter. 2.8.7, 1, 2, 3, 4, 5, 6, 7, 8, 7, 1, 2, 3, 4, 5, 6, 7. So sodium atom plus chlorine atom gives us sodium chloride. Now you have the arrow, and sodium chloride is going to be Na plus and Cl minus. Sodium ion is going to be 2.8, and when we form the ion we put it in the square bracket. Sodium 1, 2, 2.8, 1, 2, 3, 4, 5, 6, 7, 8. That one electron here will be transferred to the chlorine atom, chlorine ion. So sodium plus and chlorine also will be an ion, chloride ion. It will be in the bracket. So Cl 1, 2, 8, 1, 2, 3, 4, 5, 6, 7, 8, and one more shell. 1, 2, 3, 4, 5, 6, 7, and we have the one electron from sodium, so it's a dot. Okay, guys, close this bracket and put the negative sign. Does that make sense, guys? Okay, let's look at another example of an ionic compound. And remember, ionic compound is always between metal and non-metal. So let's look at magnesium oxide. So we're going to form a ionic bond with magnesium oxide. The first thing we need to notice, we break down this problem, okay? Magnesium atom, what is the electronic configuration? The proton number is 12, so it's 2.8.2. So for magnesium to become an ion, it needs to lose these 2 electrons. When it loses 2 electrons, it becomes 2.8. What is the ionic form? Mg2 plus. You see that, guys, the difference between magnesium atom and magnesium ion. What is the ionic equation? So we start off with magnesium metal, and what do we get? We get magnesium 2 plus, and because there's a 2 plus here, we have to add this with 2 electrons. This is different from sodium earlier on, because sodium was only dealing with 1 electron. For sodium we did Na gives us Na plus plus E minus. When we deal with aluminium, aluminium is 2.8.3. It loses 3 electrons. So for aluminium it would be Al gives us Al 3 plus plus 3E minus. Do you see how this works, students? So now we focus on magnesium. This is the ionic equation. Now for oxide, oxide is basically oxygen. So oxygen has a electronic configuration of 2.6 because it has 8 electrons. This is oxygen atom, okay guys, not the ion. For oxygen to become oxide ion, it needs to gain 2 electrons. When it gains 2 electrons, it becomes 2.8, and when it gains 2 electrons, it becomes O2 minus. Why minus? Because it's gaining electrons. So what is the ionic equation for oxide ion? The same way, except the plus takes place on the left hand side. Oxygen atom plus 2 electrons, because we've gained 2 electrons, gives us O2 minus. The ion is always on the right hand side. Now, students, I want you guys to study these two equations. Notice the difference. When it's positive, when you form a positive ion, the metal is by itself on the left hand side of the equation. On the right hand side, you have the ion and you have the electrons. When it forms a negative ion, you have the atom and the electrons on the left hand side, and you have the equation on the right hand side. So after this, I'm going to do about 3 or 4 equations for you guys to show you the difference. Now we need to draw this out. How do we draw it? The steps to draw: magnesium atom plus oxygen atom gives us magnesium ion and oxide ion. So we draw this step by step. Magnesium atom has 12 electrons, 2.8.2. So Mg 2.8, 1, 2, 3, 4, 5, 6, 7, 8, 2.8.2, 1, 2, plus oxygen has 8 electrons, so 2.6, and we use a cross, 1, 2, 1, 2, 3, 4, 5, 6. Okay guys, now we get our ions. Whenever you get ions, put them in the square bracket. So Mg first, 2.8.2 becomes 2.8, 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, and magnesium is 2 plus. We don't put a plus sign over here. You only put the plus sign when it's in atom form. In ion form, there's no plus sign over here. Oxide becomes 2.8, so O in the middle, cross 1, 2, 1, 2, 3, 4, 5, 6. Initially it had 6 electrons in the valence shell. Now it's taken the 2 electrons from magnesium atom. So those 2 electrons, you put it as the 2 circles. This shows the transfer of electrons. Close the bracket, 2 minus. Does that make sense, guys? Now, you understood how to draw these ionic compounds. We're going to practice more and more ionic equations, okay? So for example, if I have lithium fluoride, okay, I want to form an ionic compound with lithium fluoride. How will I form the ionic equations? So we take lithium, we take fluorine. Lithium has, in the atom form, 3 electrons, 2.1. For it to become stable, it needs to lose this 1 electron. So, how will the ionic equation be? Lithium metal becomes lithium ion, Li plus, plus because it loses 1 electron, plus E minus. See how the equation is formed? Now, for fluorine, in the atom form, you have 9 electrons, so 2.7. For it to become stable, it gains 1 electron from lithium. Okay, so how is the equation? F, which is the fluorine atom, and here we plus the electron because it's gaining the electron, plus E minus gives you fluoride ion. So this is something very important, guys, for the ionic equation. For the positive, the electron is always on the right hand side. For the negative, the electron is on the left hand side. Okay, guys, let's do another question. Let me see. I can do, okay, calcium chloride. So calcium chloride. Calcium metal has a proton number of 20 electrons, 2.8.8.2. Okay, for it to become an ion, it needs to lose these 2 electrons. So it will become Ca2 plus. How is the ionic equation? Calcium metal becomes calcium ion, and because of 2 plus, plus 2 electrons. For chlorine, think, guys, fluorine, chlorine, bromine and iodine is all going to have the same format of solving because they are all group 17. So Cl, chlorine atom, plus 1 electron gives us chloride ion. Same thing like fluoride. So now we know how to form the ionic equations. Let's go ahead and draw calcium chloride. So now, when you draw your ionic equation, you need to know how the compound looks, okay? So calcium is Ca2 plus, chloride is Cl minus. So you end up getting CaCl2 as your ionic compound. When you draw this, guys, you will have one calcium ion and 2 chloride ions. I'm going to show you how to draw this. The first step, you draw calcium metal and chloride ion, chlorine atom, sorry. So calcium is 2.8.8.2, calcium, so 2.8, 1, 2, 3, 4, 5, 6, 7, 8. Another one, 1, 2, 3, 4, 5, 6, 7, 8, 2.8.8.2. Sorry for the unneatness, guys. 2. So 2.8.8.2 plus chlorine. Chlorine is going to be 2.8.7. But because we have 2 chlorines, what we're going to do is we're going to put 2 chlorines, okay, guys? So 2.8.7 XX 1, 2, 3, 4, 5, 6, 7, 8, 8 chlorines, and we have another chlorine. And because they're both chlorines, they can both have X's. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. 7, 1, 2, 3, 4, 5, 6, 7. Oh, I forgot to put another shell here. 1, 2, 3, 4, 5, 6, 7. The product we get is, remember, we have calcium donates 2 electrons, okay, because it has 2 electrons in the valence shell. Each chlorine needs 1 electron to become stable. So the calcium will give 1 electron to this chlorine, 1 electron to this chlorine. Now everything becomes stable. So you put the calcium in the middle, you put the chloride ions surrounding calcium. So chlorine, Cl, 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. It becomes 2, 8, 8. 1, 2, 3, 4, 5, 6, 7. And the last electron is the one from calcium, the minus sign. Now we do calcium. Calcium is going to be 2.8.8. 1, 2, 3, 4, 5, 6, 7, 8. And 1, 2, 3, 4, 5, 6, 7, 8. 2 plus. And we put the other chloride ion over here. 1, 2. 1, 2, 3, 4, 5, 6, 7, 8. And 1, 2, 3, 4, 5, 6, 7. And the 1 electron from the calcium minus. Does this make sense, guys? Now try to practice if you're not sure, but don't worry about it. We'll be doing some questions on this, guys, at the end of this chapter. So just remember, when you form ionic compounds, look at the chemical formula first, okay? If you have something like MgCl2 or CaCl2 or these kind of ionic compounds, you have 2 chlorines and 1 magnesium. So the 2 chlorines surround the 1 magnesium. The 2 chlorines surround the 1 calcium. If you have something like NaCl, it's more straightforward. And we know how to do the equations, right, guys? If we have MgCl2, it's going to be Mg gives us Mg2 plus 2E minus. If we have Cl, it will be Cl plus E minus, giving us Cl minus. Okay, guys, this is it for ionic compounds. We're going to next do covalent compounds, so I'll see you there.